Okay, I'd just like to quickly compare logic and set theory, comparing some of the things that we've been talking about in logic to some of the things that we already talked about in set theory, make some of these connections. And we've alluded to some of these throughout our discussion of logic, but I just sort of want to go through and quickly summarize them. So, first of all, statements in logic. Those are the objects that we've been working with. And in set theory, the objects we were working with were sets. Now, for logic, for a particular statement, one of the first things that we started analyzing was its truth value. When is the statement true versus when is the statement false? In set theory, that's equivalent to the existence of an element in a particular set. So we can sort of think of this as if we're saying that when a statement is true, that's the same thing as having an element inside of a particular set, versus when a statement is false, then the element is not in the particular set. The negation of a statement is analogous to the complement of a set. And now that we have these first three pieces, we can sort of build a link between all of them because, so recall the complement of a set, that was the set of elements not inside of a particular set. So it was things in the universe that weren't in a particular set. Now, when we negate a statement, we're basically saying that when the statement is true, its negation is false, and vice versa. Now, those truth values correspond to existence, and to say an element exists in a particular set is equivalent to saying it does not exist in the complement. And vice versa, if it doesn't exist in the set, then it must exist in the complement. So think of elements being in the set as cases where the statement is true, and elements not in the set as cases where the statement is false. And we see that there's that same relationship between a statement and its negation to a set with its complement. Now, the disjunction corresponds to the union of two sets. Remember, the disjunction, this is the or statement, and the union of two sets, this is where we take all the elements that are in the set A or B, and we put them all together. So when we take the disjunction of two statements, we're taking the cases where one statement is true or the other statement is true and putting them together. So it's sort of uniting the two statements and saying, okay, if either of these statements are true, then the disjunction is true. And so we're pulling together all the cases that have true truth values. Just like for set theory, we're pulling together all the elements that exist in one set or the other. Similarly, the conjunction and the intersection are linked. For the conjunction, the and statement, we're only taking the cases where the first statement and the second statement are true. For the intersection, we're only taking the elements that are in the first set and in the second set. And so again, these two things are linked. And we actually see this with the notation as well. The notation for the union being the U, and then the notation for the disjunction being that sort of V shape, the upside down caret. And then the intersection being the cap, and the conjunction being the caret. So notice how the conjunction and the intersection both open downward, where the disjunction and the union both open upward. And none of this is accidental. And you can use this as a tool to help remember which symbol is corresponding with which operation. One other connection we can make is truth tables to Venn diagrams. And again, this would be a little more abstract of a connection, but again, we use them both to visualize, right? The truth table allows us to visualize truth values of statements, and Venn diagrams allow us to visualize existence within set theory. So they're sort of analogous to one another. But, here from these connections, we build a lot of other connections. For example, we've talked about De Morgan's laws, and De Morgan's laws for logic and set theory are tied together. And really, it comes from just replacing things like complements and negations. Unions and disjunctions, intersections and conjunctions, and so on and so forth. So if you study these two subjects further, logic and set theory, you'll continue to find more and more ties between them. Another quick example is the number of cases we put inside of a truth table is tied to the number of subsets of a particular set. Remember, if a set has n elements, it has 2 to the n subsets. if a compound statement has n simple statements, there are 2 to the n different cases for its truth table. And again, these are just a few examples of the connections between the two subjects.